Hi everyone. I'm here in London. I don't live here. Passed by for the week. I just said to my colleague Anna, hey, maybe I might come to do a talk. I've been coming on and off London, but I've never been here on the last week, on the last Wednesday, on the fourth Wednesday of a month. Never. Like, it never happened. It has been crazy. So this time it happened, so I had to submit a talk and speak. So this is my Twitter, @MatteoCollina, tweet something, make questions, ideally, or not, or whatever. I'm going to talk about some interesting stuff right now. Typically I wear a hoodie, by the way, like this is whatever. I was at a client. So I typically wear a hoodie and a t-shirt, okay? Let's be, okay? Some of you work on Node, or some of you are curious, but it happens to everybody that you got called at some point at Sunday morning at 7 a.m., okay, because something went bad on some server, somebody's laughing, okay, and didn't have a really nice time about it. Like, I don't know, it happened to me several times, as everybody, okay? It's everybody has been on call, or the team was small enough that there was nobody really on call and everybody was on call. I don't know. What typically happens if you're in this situation and you receive an alarm, it's because you did something wrong, okay? And that's very normal, that's very typical. And you get this alarm, and typically goes around with the second alarm. Like, you get the maximum number of servers. Like, this application is slowing down. You have 10 or 20 servers running on AWS. Your elastic load balancers have reached your limits, and the board is burning. And your manager calls you, shouting at you on your phone. Get that thing online, please, okay? Typically what everybody does at this point is they do what they call the poor man fix. What does the poor man does? It's also called a Windows person. It basically, you know, it reboots the server, throw more hardware at it, and it's done. That's been a very nice joke. It's not crashing anymore, by the way. Like, it didn't happen for a long time. I also have a Windows machine, so I need to test some stuff from time to time on Windows. And now everything is calm again, and you can go back and relax. Fun story, it happened a similar situation to me some years ago when a lightning struck the Dublin data center of AWS, and I had to rebuild some server on the 15th of August, and I was on vacation. It was not a good experience overall. Anyway, this is a calm situation. Everything is fine. It's fine again. So back on Monday, what you do? Well, you're looking at what the problem was, because you don't want to be really notified in the morning, okay, of a Sunday or whatever. We don't really like to work in a panic situation, in a stressful situation. We like our things to run smoothly and not be bothered. Like, we are lazy developers, right? So we need to look at what happened. This is a typical very hard problem, because some of the production problems are really hard to replicate, okay, are really hard. My application runs fine on my machine, right? So why that doesn't run on my servers? That's a typical, if it runs on my machine, if it compiles, I don't know. After we understand what happened, we need to look at how to fix this problem. So first of all, we need to gather some diagnostics and evidence. So wait a second, the problem happened the day before, so how can we gather data and evidence now? Typically, a lot of production deployments should include what is called application performance monitoring solution, which is dubbed APM by everybody. And which basically, what it does, it basically collects some metrics and does some tracing and monitors some errors, and it can tell you more or less what went wrong. Typically, you can see that database over there at this nice query that you forgot to optimize. Somebody on the team said, nah, I'm not going to optimize that stuff. It's just, nobody's going to eat that endpoint, and then that endpoint brought everybody down. Very typical, another very typical situation. once we have gathered the data and evidence, and we know that that endpoint is what brought us down, we start reproducing. We need to reproduce the problem in a non-production live environment. What does it mean? You need to have a separate environment deployed on AWS, Azure, Google Cloud, your Raspberry Pi on your basement, I don't know, some data center somewhere in the world, which needs biometric, the retina scans to enter, you decide. Okay? You need to have a way to reproduce the problem in an environment that is as similar as production that you usually use. And after you've done that, you can gather some more data and evidence, and you can pinpoint the problem and to reproduce it in a very synthetic way. So something that you can run on your machine, because coding on servers and trying to fix live problems on servers is very, very hard. Don't try to do it, okay? Please raise your hand how many did this in the past. Perfect, okay. I'm super culprit of all of this, okay? Like super, super, super. Anyway, the right approach is reproduce the problem in a synthetic way. So something you can work on your machine. If you can reproduce it on your machine, you will be super slow in fixing the actual problem. So if you fix the actual problem, if it takes like a week to fix the problem, it's probably too late. So. And then we try a fix. We finally got to coding. Like, it took a long way. And then if not fixed, go back again, because, you know, nobody gets it at the first try. So, so this is a nice diagram, okay? It took me 2 hours to do this. Please appreciate my art, please, okay? So we have our performance issue, and then we diagnose this. We get some diagnostics from the production environment, which is typically coarse-grained and also polluted. So what I mean by polluted is it means that there is a lot of data from a lot of other endpoints and sources, and it's noisy. So it's very hard to understand exactly what's going on. Maybe I got a hunch, but it's not perfect. So from there, I need to try all the different roads, and I can reproduce it on a non-live environment. This is a very hard step as well. Then I get some more clean diagnostics, and then I will finally able to run it on my machine. And then more data, and then walk the dog. That's the typical solution for Node.js. I have a dog, I walk the dog to fix performance problems. Somebody else can like staring at the screen for a long time. Before having the dog, I used to do that. Long time. It's very hard, because Node.js is exploded, and all the tooling for gathering data and interpreting the data is not really easy to use. Big disclaimer, I have been the guy staring at the screen and walking the dog for some companies around the world trying to fix their problems, okay? So I know a thing or two about this step. Fixing performance issues, it came about a very simple process, that question mark, okay? First of all, you need to establish what I call a measurable goal. Okay, so given a situation, you want to know exactly what is your target. And then you measure. And if there should be a gap between the two, so if you want to improve. If you don't, well, I finished. Maybe not, I had a problem. So you have a measurable goal, you measure, you find what is called the bottleneck, which is what is preventing your application to reach your goal. And you optimize and fix the problem. You measure again. Whoop, sorry, I didn't mean to do that. Establishing a measurable goal is the most important step. Most people forget about it, okay? Because improving the performance of some code is a never-ending process. It's a complete rabbit hole. You can go down deep in trying to optimize Node and be there 3 years later, keep doing the same thing, because there is no end to it, okay? If you don't establish a measurable goal, you loop into the process, you never exit. So you need to always establish a goal to what you want to reach. So how do you establish a measurable goal? I don't know, you can throw something like this, randomly taken from the web, you know. You want to reply at under 200 milliseconds for 100 concurrent requests, 99% of the cases. Something like that. Okay, it can be even 2 seconds for your application. It's not need to be 200. Okay, it can be 20, by the way. Okay, Node.js can go as fast as you want, depending on your business logic. You need to remember one important thing when developing Node.js application, that latency and throughput are always connected to each other, mainly because Node.js has one single thread. So if it's processing something, it's not processing something else. And it's true that it runs multiple I/O access in parallel, but when one of those queries gets delayed, so if one query gets super delayed for whatever reason because it lacks an index, okay, so the database gets in trouble and then some queries get delayed or takes like, I don't know, half a second or a second to reply. Typically that means we increase concurrency. So we have more queries running in parallel, which means that we have more memory usage because we have more in-flight data. So the number of requests that are flying in parallel in my code are, it's just more data, because instead of having like 100, now I have 200 or 300 things running in parallel. I have 100 concurrent requests coming in, okay? Which increase memory usage, which an increase in memory usage will have an increase in garbage collection activity. So because you have more memory, you are allocating more memory, so your garbage collection is going to be have more work to do, and more work to do means more CPU that I'm going to run with more CPU. I need more CPU power to run my code. So all of these variables are all connected to each other. So if you just, from time to time, a problem related to slow I/O can show up as a memory leakish situation where your application goes balloon to 2 gigabytes of memory, but in fact it's just an I/O issue from your database. So it's very hard to understand exactly what's going on because all of these things are connected between each other. So going back to what I call benchmarking-driven development, establish a measurable goal, measure, find the bottleneck, optimize, fix, measure, and fin. Now, it's not really a very good way of a very good acronym, but here is my try. Yeah. So measure. So how do we measure? A couple of years ago, I wrote this little thing called autocannon. Autocannon is an HTTP 1.1 load tester written in JavaScript, so in Node. You can use it to do load testing against your web applications. It's nice because it's written in JavaScript, so it can be fully scripted in JavaScript. So you can configure which type of request you want to send. You can send multiple requests at the same time, and so on and so forth. It's really simple to use. It's also really fast. It uses its own HTTP parser. Actually, Tim Caswell, but whatever. It uses a very fast HTTP parser that is not in one in core, and it has a non-complete version HTTP implementation, which is very fast because we avoid to do a lot of things because we just need to hit endpoints a lot, so we can cheat we can cut a couple of corners that Node.js cannot do. You can check it out. It's very easy to use. It also runs on Windows, which is, it's, as I said, I started saying Windows, so I keep saying Windows. And it's always hard to install those type of things on Windows. So you can also run it on Windows. It runs very well. npm install autocannon, or even npx autocannon, and it just runs. So very nice. How do you use it? Well, you start your server, then you hit autocannon. There's a nice progress bar, and then it prints some latency and whatever. It uses a very fast data structure to collect this data, called HDR histogram. It's really handy to use that if you need to compute statistics data and so on. It has 0.1 insertion time on the structure, which is very useful, and it's fairly new and not really most people know about it. So it's worth talking about it. Look at autocannon dependency, you will find it. So, well, we have established our goal. We have been measuring, and then we need to find the bottleneck. It's good time for diagnostics. Diagnostics is one of the hot topics for Node.js for 2018. We have been with others on the TSC and on the diagnostic working group at a nice summit in Ottawa in February. It was super cold. Okay? Discussing on how to improve the situation. Okay? As you probably, if you have run Node.js in production, you probably know that you might be lacking some of the instruments that you have been using, some of the tools that you have been using in previous platforms. So this is what we have been developing at Nearforms called Node Clinics. It's open source. You can try it. It's Apache 2, so whatever, do whatever you want with it. So let me demo this. Oh yeah, so Node Clinic, you install it, npm install Node Clinic -g. It has several commands. One is Docker, another one is Flame, and there are more tools to come, so we keep working and extending this product to add more stuff to it. So first of all, Clinic Doctor. So Doctor enables you to self-diagnose your application and know what to do next. You run like this. So Clinic Doctor -- node server. You need to pass the node executable so you can test it with Node Master if you want to. Okay? Or you can test with different versions of Node and whatever you want. So wait, I'm going to run a demo now. So here we go. I have some demos here. So Clinic examples. Okay, and then I've run this a lot. So what we can do is Clinic Doctor -- on port. This is a new flag that we have added so that we can run autocannon automatically for you. So on port autocannon does C100 concurrent connection D5 for 5 seconds to localhost at port. So we get a nice environment variable. So node slow event loop index. This is an example with a slow event loop application. Okay. Now I am on battery on a MacBook 12-inch attached to a projector, so whatever I'm doing, demo gods might not be with me. This is a very slow application. After you have run, it analyzes the data and it prints it out. Here we go. So this is Doctor. We have a bunch of things, very interesting stuff. We monitor the CPU usage, the memory usage, the event loop delays. You see it goes balloon, and the number of active handles. The number of active handles is very useful to understand the number of concurrent connection you are having. The number of handles, so what is a handle in Node terms? A handle is a low-level resource. So imagine a file descriptor, a socket, a file, whatever you want. That's a handle, okay? So these are the number of active handles that we track. And we also have an event loop delay. We use a very hard to understand, I couldn't, statistical model to, even talking with data science, Andreas Madens that wrote it did a fantastic job, to detect the waveforms for all these patterns and combining the data together to detect various issues. One of these is the event loop delay issue. So you can see event loop delay. It can detect more than one. And it offers some recommendation around here. Let me try to zoom in. Okay. It offers some recommendations. So there may be one or more long operation blocking the thread. And it says, mitigate, implement 503 event loop protection. How many of you know what a 503 error mean in HTTP? Service unavailable. Yay! So what it does, it tells your load balancer to try somebody else. Okay? More or less, you are saying if your event loop is going balloon, you might want to tell, hey, load balancer, don't send anything this way because I won't be able to reply anytime soon. Or pull me out and kill me. I don't know. Depends on how you want to handle the stuff. Okay? But whatever. How do the unknowns? Well, you want to just find out what CPU intents, what is blocking the event loop. There is also a long discussion and explanation and blah, blah, blah that one of my colleagues, David Malclemens, wrote. It's fantastic. You might ask what I did about this. 0. One thing I did. Basically, I worked with a statistician for a couple of months to actually code the waveforms. So they came from my brain. I'm joking. Anyway, so this is Doctor. You run this way. This is the image. So now Clinic Flame turn. Okay, Clinic Flame is built on this tool called 0x. You might have already seen it. It's a flame graph tool. How many of you have used a flame graph in the past? Some people. Hey, good guys. So 0x makes running this very easy. So we can run it in this way with Clinic Flame and run nodes, low event loop index. And it's going to, Clinic Flame is going to ask me for my root password because I need to because it needs to use dtrace. Dtrace runs only on Mac. On Linux, it uses a thing called perf, which is more or less, it's similar. It does stack sampling. So it collects all the stacks of your applications. And then it enables us to print the stack trace. Now, this projector completely destroyed the visualization. The code is not seen. This is a function called sleep. Okay, there is a theme button. Let me try the theme button. Did it change anything? It's even worse, right? Maybe not. Maybe you can see it. It's called sleep. Okay, there's a sleep function. So now let's see the code. That's the code. Okay, that's the sleep function. Okay, so that was a very, very simple example. Okay, that's how to block the event loop. You put a function that waits for some millisecond to pass. Very good code to implement sleep, by the way. There is a new version of 0x coming out. So it's already come out, but we haven't integrated it with Clinic yet. It's V4. With V4, we can use the same on-port flags that we use with Doctor. So you can use 0x -o to automatically open, and we can do the same thing. Now this is slightly different. For example, it has a nicer emoji. Okay, it has a better terminal handling, but more importantly, it doesn't have any dependency. It can run without dtrace or perf by default. It uses some of the internal profilers from V8 to actually perform this work. And in fact, here we can see more stuff. It also has some more options. It can show you which functions are inlineable, which functions are not inlineable. It can show you optimize and optimize and other things. What it doesn't do, it doesn't sample the C++ stuff that the kernel tracing can do. It also supports kernel tracing, so you can use it as a Swiss Army knife for flame graphs. Okay. So how much time do I have left? 5 minutes, perfect. So it still supports kernel tracing. Works on Windows. Okay. Whatever. I have a Mac. I started joking about Windows. It works on Windows. One of the most requested features of 0x was working on Windows. By the way, remember that most code doesn't need to go ludicrous speed. Okay, it's not needed. Okay, it's perfectly fine to write slow code. Okay, depends on your applications. However, if you need to write fast web application, that's my web framework. Okay. There is a nice talk that I did last year called "Take Your HTTP Server to Ludicrous Speed." Check it out. Talks about this framework called Fastify. It has a very API similar to a lot of others. I had this more or less is how it compares. These are slightly outdated numbers, so take it with a grain of salt. It's a little bit lower because of Spectre and Meltdown. So these high numbers are not reachable anymore. Thank you, Spectre and Meltdown, and thank you, Intel. I also want to talk about logging. There's another talk that I did 2 years ago. The cost of logging, Pino, is the fastest logger for Node.js. You should check it out. It's very, very, very fast, very easy to use. It's the same API of Banyan, so you can create it, blah, blah, blah. I've been working a lot on making code fast, okay? This is the performance difference on taken last year on Pino. Whatever, take your decide. Make your choices. Acknowledgements, I would like to thank Nearfirm because I wouldn't be here if it wasn't for Nearfirm in a very true sense. Nearfirm sent me to a client and I just decided that I was going to speak here. Also thanks Nearfirm for my time on Node Core. I am on the Node.js TSC. I am paid to work on open source, so thank you for using Node and for using all the stuff that makes this community great. So that is that. If you have any questions about Node, any curiosity, any doubts, any problems, any complaints, whatever, come to me. I want to hear about all of them, okay? Especially if you have Node streams. If you have problems with Node streams, I am the guy for Node streams, okay? I am maintaining that stuff. If you ever you have a problem with readable dash stream, which is the thing that all the time you download with any Node.js project that you are running, please come to me. I publish that. So it's probably my fault. I want to thank everybody on this picture very quickly. Andreas, which was a data scientist that did the magical thing with Doctor. Joy, that did the design. Connor, my boss. And Matthias Boos, you probably know this guy, Macintosh on GitHub. He worked a little bit, he's working on these tools, on the next tool that is coming out. And Alan and Camille are working there as well. And David Mark Clemens that wrote 0x and is keep maintaining it. And this presentation, not this the previous version of it, I will deploy this one sooner rather than later, is available here. And this is me, hey, whatever, a lot of open source. And thank you. If you need help with Node.js, we are in business, so that's what it is. So, bye, folks.